What's going on, everybody? Welcome back to my channel. For those of you who don't know, my name is Adam James. I'm gonna go over what I do as a product design engineer. For full transparency, I am a product design engineer at Amazon Lab 126 and have held this position for just over 2 years now. The views and opinions expressed in this video are those of my own and do not reflect the official policy or position of Amazon. Get a snack and sit back because this video is gonna be a bit on the longer side, so let's jump right on in. This question was actually brought up by a student that I was mentoring through an organization called Breakthrough Silicon Valley. They assist low-income first-generation students for success in college preparatory high school programs and entry into college. If you'd like to check them out, I'll leave a link to their website in the description below. The student asked me what a product design engineer is, and as I searched for an answer, I really started to realize that there maybe isn't a one-size-fits-all response. As product design engineers, also referred to as PDs in the tech industry, we really do a lot. Design, tolerance analysis, product intent, data analysis, ideation, the list kind of just kept going on. And depending on how large the company you work for is, and essentially the number of responsibilities that company can allocate to different teams, the tasks that PDs have to tend to on a day-to-day can sometimes be a bit overwhelming. Let's create a scenario here. Let's say you want to become an electrical engineer. You're typically going to study electrical engineering. And if you want to become a software engineer, you're typically going to study computer science. And if you want to, say, become an industrial designer, you typically study industrial design. But what about a product design engineer? Do you study product design engineering? To become a product design engineer, you can honestly study a wide variety of engineering practices to get to that same end goal. I would really say it's more about what you enjoy doing day to day after you accomplish that degree and your experience within projects that are both personal and academia that you are passionate about. I do want to note, right, the career does typically require an engineering degree. As we do a quick search on YouTube, it looks like we need a little more transparency about this role and really the roadmap that allowed me to get to, well, where I am today. Through this video, I hope to provide some clarity not only to students interested in becoming a PD as a career, but to all my friends and audience who ask the question, what do you do as a product design engineer? So I sectioned this video into 5 subgroups so we can fully understand the question at hand. What is the definition of a PD? What did I do to get to where I am today? What does a day-to-day look like as a PD? What does work-life balance look like as a PD? And how is a PD different from an industrial designer? So what is the definition of a PD? Product designers work to design and develop physical products that customers are looking to purchase. They research new and interesting ideas and processes for new or existing products. They may also improve product design for increased performance and functionality. A PD is essentially an engineer with a passion for problem solving using both quantitative data and creative design solutions. They want to take a hardware idea and use prior knowledge to approach a design problem in, say, a new way which benefits both A, the functionality of the product, and as well as B, the presentation to the end customer. When a PD sees a customer smile after holding and using a product they've designed, it's honestly the best feeling in the world because, we as PDs know how much thought went into that product to ultimately achieve customer satisfaction. So how did I get to where I am today? When I was a kid, I always loved building things. My parents even just had a side yard where they would just let us have at it. And so we ended up building a BMX dirt track growing up. And I would just spend countless number of hours with friends and family building jumps out of dirt. And as I got older, I started to kind of get into skateboarding and, decided it was only proper that I ended up making my own jumps and rails. But what's really interesting to me is I was really never all that great in math. But what I didn't know was that in order to achieve a successful skateboard rail correctly while, maybe at the time I was doing it through trial and error, there's a lot of quantitative data and measurements that really need to align so that a person, depending on their weight, of course, can successfully use that product without the rail failing. I absolutely loved physics. Looking back, I truly think that it's due to the fact that physics forces us to kind of use math as a tool to solve real problems which are then validated in real life. The whole conservation of energy and the bowling ball on a string test really had me hooked. So in high school, I took 2 engineering courses. I ended up staying late after school just to use the CAD software because I couldn't afford it at home at the time, which, you know, it's why I'm such a huge supporter of Fusion 360. Shameless plug here for some of the tutorials I pump out on this channel, because that kind of accessibility to CAD, it didn't even exist when I was a kid, and that wasn't even that long ago. Now, when I was applying to colleges, I was specifically looking at, you know, mechanical engineering degrees. I looked at Oregon State tuition. I was currently in Washington at the time. Out-of-state tuition was very expensive. And then I also looked at Washington State University for their ME programs. I applied to Western Washington University, and we'll get to more of that later. So in my senior year of high school, we had a senior project. What we needed to do is I needed to identify the project itself. You had to learn something, and a mentor to help me, right? And so I'll let it be known that I actually still keep in close contact with my mentor to this day. So I decided on the project I would build a composite fiberglass Baltic birch longboard that I would design in CAD and then fabricate myself and, you know, ride it through the hills of suburbia. And the mentor that I selected for the project was a hardware tooling engineer at Microsoft at the time who went to Western Washington University in Bellingham, Washington, to study it was a dual major at the time. I believe it was plastics and manufacturing engineering technology. And when he allowed me to visit his office this time for the senior project and assisted in making and designing this longboard for my project with me, I know at that moment, that was what I wanted to do. You know, as a tooling engineer, he provided me like direct exposure to what it takes to become an engineer in the field of consumer hardware electronics. Now, let's take a step back here, right? Degree in plastics manufacturing engineering technology to tooling engineer. I asked my mentor about his thoughts on kind of where I should attend school and if my goal was to become an engineer, you know, involved in the field of consumer electronics. And I asked if it was mandatory that I get a degree in, say, mechanical engineering. And to my surprise, his answer was no. My knowledge gained through both the education I received at Western, as well as the valuable experience I learned in industry, led me to where I am today. And, you know, I never really forgot that simple message, and, you know, quickly realized I wanted to go to Western Washington University and study plastics engineering technology. And after high school, I set off to college and applied to become a pre-major in that program. And to my disappointment, the program actually changed from plastics engineering technology to an ABET accredited plastics and composites engineering program within my first year attending. What did that mean? It basically meant more math, which I wasn't super happy about. Where this PCE program differentiated mostly from an ME program, you know, an ME program will go into CAD, quality assurance, statics, mechanics, math, physics. But what about injection molding? What about manufacturing a real product? You know, the PCE program really focused on designing for mass manufacturing, processing, tooling. I'm not talking about from a textbook, I'm talking about real learning from real experiences, right? Designing a product from CAD and 3D printing a proof of concept, then designing the metal injection molding CAD, and then running mold flow to validate the design, the flow path, the cooling lines, and the ejector pin location, and actually bringing that steel, well, in our case it was aluminum, block of metal to a CNC machine to run G-code operations created by us to then fabricate the mold. You know, we had not only a large manufacturing lab to use at our leisure, but industrial injection molding machines where we could personally load in our own molds and then modify and test those processing parameters to achieve a product ready to be mass produced. Western Washington University has so many resources for their engineers to use and learn from, and I couldn't speak more highly of their plastics and composites engineering program, especially after being, you know, in industry for over 4 years now. Once I graduated, after applying for a while, I decided to start my own product design engineering company. And at the time I did, you know, 3D printing and prototyping in-house. As I was developing that business, I actually accepted a job at a company called Autodesk as a mold flow technical support specialist in Portland, Oregon. And then I remember being like, oh, I'm hesitant on accepting this position. There's no engineer name in the title. And at that moment, I remember what my mentor told me. The knowledge you gain through both the education you receive in school as well as the valuable experience you learn in industry will lead you to where you are tomorrow. And you know, at Autodesk, the amount of injection molding experience I gained while holding that position was amazing. And after working at Autodesk for about 2 years, learning and providing mold flow expertise to different companies, I accepted my role at Amazon as a product design engineer. And I truly believe that my passion for both product design and the real world experience that I gained developing products at Western, my college, right, as well as my company and Autodesk helped me to get to where I am today. So what do I do as a product design engineer day to day? To answer this question, I think we need to start with the goal of a PD. The goal is to successfully bring a product from ideation to mass production. And that could be anything like an accessory or a consumer electronic, an airplane, a car, anything hardware, hard goods is what I'm referring to here. PDs, at least at Amazon Lab 126, work with a close-knit project team, including a PD team manager who may actually manage many different teams, but has a high-level overview of essentially the product goals and intents of that particular project that you're working on. You'll then have a PD technical project manager, also known as a PD TPM, who essentially attends each PD meeting and keeps cross-functional groups and leadership up to speed with our current design updates. Typically there's one of those per team. You'll have a PD tech lead who is typically a PD by job title and has a similar background as a PD, but with more ownership and seniority basically. They typically help manage technical subsystems with the PD engineers specifically, and then of course we have myself, the PD engineers. And as PDs, we say on Mondays, we'll wake up around 8 a.m. if I'm lucky and start work around 9 to 10, depending on, how late I was up the night before, of course. And typically I'll open up my email, and if it's under 100 since when I closed it the night before, then it's a good day. I'll tend to the most critical emails, which, accompany the design components I own first, and reply with an answer quickly if I know it, or, if I can see if I can find that answer and it's a design-related question in CAD. Then maybe I'll be able to answer that myself, and then attempt to open any CAD model and remember that it takes about 15 minutes for an assembly to generate, so I'll go grab a cup of coffee. We then usually have a PD sync. This is at least weekly, and we go over each engineer's components that they own and kind of the status update associated with them. Are there any blockers? Who can help communicate that to other cross-functional groups? And, what meetings might need to be scheduled later that day or week to close out that issue. Many times different cross-functional teams are involved in, say, one single design decision. So communication from a PD perspective is super critical in really ensuring that design updates meet cross-functional requirements. I would say the day could then consist of checking in with all group chats via our version of Slack, which is called Chime, and seeing if there's anything urgent to tend to. Depending on the day, I'll focus either on CAD design, be in emails answering questions, reviewing DFM, which is shorthand for design for manufacturing, changing my designs in accordance to them, reviewing waivers from suppliers, creating 2D drawings, running TAs, more on what a TA is later, tending to issues posted on Jira, it's our issue tracker, sending off prototypes, picking up prototypes, reworking devices to validate with cross-functional teams to test so we can validate a particular design change, running statistical analyses to identify supplier capability, or essentially in meetings all day about issues that are currently present or on the rise. I would say it's pretty unusual if there aren't a lot of meetings throughout the day as a PD, especially while working remotely. Once 4 to 5 o'clock hits, we get hit with what I call part 2 of day 1. Basically, in the consumer hardware electronics industry, we do some prototyping or early concept builds domestically, but when it comes to mass production, especially in volume, we tend to work with contract manufacturers, also known as CMs, in China, and essentially do everything I mentioned above, but now again with them to ensure alignment and a path forward for a build. This definitely calls for some late nights, and typically allows you to start your next workday a little later as a result of being up so late the night before. I'd like to provide an example of, say, a change request from another cross-functional team. Let's use, say, the Apple AirPods Pro, for example. Let's say the industrial design team wants to reposition the LED on the charge case from where it currently is positioned to a lower position. It sounds like a super simple change, right? Well, it depends on a couple things, or multiple things. How far into the build cycle are we? What other components need modification because of that change? It's kind of our duty as PDs to find out and see if we can find a solution while also achieving sign-off from every other team that may be impacted because of it. ID wants a brighter LED, so what's the impact on the thermals of the device? A design conversation we need to have with our thermals team. Do we need another driver? A conversation we need to have with our thermals, optics, and electrical engineers. Is this electrical component moving closer to a Bluetooth chip? If so, how might that impact Dsense performance? Do we need a larger or a stronger LED? This may be associated with cost and supply chain, and then we need to understand if that component interferes with, say, a heat spreader inside the current architecture. Each and every design investigation is just that. It's an investigation. And until we as PDs understand and identify a path towards a solution, we can't say with 100% certainty that we can make that change. So what do I do in CAD? Well, PDs work in CAD very often. CAD is a design software, also known as computer-aided design, to assist in creating basically 3D models for products our customers use each and every day. We partake in high-level architecture analysis. We align with cross-functional teams to gain understanding of design intent and limitations. We see if all the Lego blocks can fit in the box, essentially. It's a little more complex than that. As PDs, we also participate in prototype development. We also spend a portion of our time doing tolerance analysis. For example, let's say we have an auxiliary port which is mounted to a circuit board for a speaker. Around that circuit board, we have a plastic housing with a hole cut out so a customer can plug in their phone with an aux cord. We want to ensure that the max deviation that auxiliary port might move upon assembly and component tolerances will not exceed the center-to-center housing hole, the aux port hole alignment needed to properly plug in an aux cord. You know, if the tolerances are too wide, the housing hole where a user plugs in that aux cord may not align with the port, which results in a use case where essentially the device is not usable and the customer is dissatisfied. After designing in 3D CAD, we do 2D drawing creation. We call out FAI measurements to communicate to our suppliers. FAI stands for First Article Inspection. In these 2D drawings, we also call out critical to function measurements. We call out process capability measurements and call out different DOEs to identify different materials and processes that we might need to test in a particular build for a component or subsystem. We have meetings and sync-ups with suppliers. I do also want to mention the cross-functional engineering teams that PDs in the consumer hardware electronics industry work with on a day-to-day basis. They are electrical engineers, industrial designers, audio engineers, adhesive scientists, wireless engineers, sensor engineers, reliability engineers, optical engineers, CAD EE layout engineers, process engineers, manufacturing engineers, tooling engineers, material scientists. So what does work-life balance look like as a PD? I've been in crunch times and I've been in lulls, right? When you're in crunch time, you're in a build and you wake up and you work at 9 a.m. and you work through lunch and you work until 2 a.m. to align with your China manufacturing team. But when you're the engineer behind a design and something goes wrong, there can be a lot of stress. Include alongside that coming up with a solution to that issue in a short period of time, knowing that the manufacturing line is down and there's a lot of people depending on you. But you learn so much. You learn how to stay more organized. You learn how to communicate better the next time. And you use those findings from the failure to avoid it during your next build. It kind of just comes with the role and responsibilities behind, an engineer who works so closely with so many different cross-functional teams. I've also had weeks where, because we signed off and released an okayed tool for a build, we pretty much spend the time doing trainings, maybe cleaning up and organizing CAD workspaces and catching up on documentation. These weeks are less stressful and you kind of make your own deadlines because these aren't super time critical at that point. I would say the work-life balance maybe isn't as great as some other roles, but it's simply a result of a role with a lot of ownership and growth opportunities. To make some of the coolest products in the world doesn't come without a positive attitude and a resilient mindset toward, accomplishing something that hasn't been done before. Now, how is a PD different from an industrial designer? I'll answer this question from, the perspective of a PD, of course. I'll start by mentioning that there are some similarities. We both have a creative approach to a problem. We both design to an extent, but I think where the separation between an ID and a PD occurs is when it comes to manufacturability, right? We all want all of our devices and products we use day to day to look beautiful. I mean, who doesn't? They study design history and the vision with which they want a product or a suite of products to follow and use organic shapes and objects to form a beautiful product which customers will love. Their expertise in visual design literacy, computer graphic imaging, and knowledge of design history goes way beyond anything I studied in school. Now, this isn't to say that IDs don't know how to manufacture a product though. In fact, I've worked with some brilliant IDs who know just about as much as I do with regards to textiles, plastics manufacturing, and tooling limitations when it comes to the overall product design. When it starts to, I think, deviate from solely focusing on design, it is in the details of the process, right? PDs dive deeper into understanding how we can successfully and consistently manufacture a product. We focus not only on the design, but the form, the fit, and the function of a device at not only the component level, but the assembly level as well. We need to understand if we can assemble our design we've developed with our ID team. We as PDs need to understand if we can mold our design and incorporate draft angles on plastic parts, right? We need to be able to see if we can assist in ejection from a tool or incorporate a uniform wall thickness so the plastic can flow uniformly through the design. I think PD to PD, it kind of varies as well. Some PDs are extremely good at CAD and others are experts in statistical analysis and stack-up and TA understanding. It's a PD's job to understand where they lack expertise, I think, and then continue to learn and grow so we can develop the best product possible. I'll end the video on this note. Whether you're a kid with a passion for design and building things like I was, someone who excels in STEM and wants to apply that knowledge in an environment which is essentially fueled by creativity, or a recent graduate from, say, a wide variety of engineering practices, becoming a PD is certainly obtainable. I would focus less so on which engineering practice will get you there though, and more on what you're passionate about. Thanks for watching. I'll catch you on the next one.